let's look at what the word equilibrium means. And I wrote here, I said, for a closed system, equilibrium is said to occur where there are no observable change in the property of the system with respect to time. I will explain. For a typical chemical reaction, which is denoted by a chemical equation, we have that a reactant, right, or several reactants undergo a reaction, right, to form a product. Right, this is what we have for a typical chemical equation, right, or a typical chemical reaction. But when we talk about equilibrium reaction, it means that there are no change in the properties. That means the forward reaction will be equal at the same time to the backward reaction. So this symbol is what we use in denoting equilibrium reaction, right? That means there are no change in the property of the system with respect to time. Any forward reaction, if we take a forward reaction, we are trying to turn the reactant into product, or we are trying to react, or we're trying to do a chemical equation, trying to form new substances. At this point, nothing will be formed. The forward reaction will be equal to the backward reaction. That means there are no change in the property of a system. Remember, for a closed system, right? But that's that for equilibrium. But in this case, we are looking at equilibrium constant, the mathematical representation of equilibrium constant. So for equilibrium constant, which is denoted by Kp, is simply the ratio of the concentration of the product to that of the reactant. Simple. The ratio of the concentration of the product to that of the reactant. Right? So let's assume that the word, and not really an assumption, the word concentration is simply a square bracket. Right? So at this point we have for product, concentration of the product, the ratio of the concentration, square bracket of the product to that of the reactant. That's simply what it means. And if we take this further, it simply means the concentration of product, right? Concentration of product over the concentration of what? Of reactant. That's what it means. But then let's assume that the product has a coefficient here of small letter, let's say y, right? And our reactant has a coefficient of small letter x. In this case, and when we are trying to represent them in our equivalent constant, what we are going to have in the product, instead of just having the concentration of the product, the y here is going to form a raised to the power at this point. So at the product side, the y is going to come here as y. Also, for the what? For the coefficient of reactant, if we are representing it in the equilibrium constant, the s here is going to form a power here, thereby forming a small letter s here. That's simply how to represent equilibrium constant. Very simple. So on the next video, I'm just going to show you some simple examples of how to represent equilibrium reaction or equilibrium constant, and give us a basic waec and JAMB questions that relates to equilibrium constant. I'll see you in the next video, guys. Alright guys, let's look at the example 1 on our topic on equilibrium constant. So example 1 says, write the equilibrium constant for the decomposition of calcium trisulcarbonate 4 to give calcium oxide and carbon 4 oxide. I'm going to give you 2 steps on how to solve problems as regard to equilibrium constant. Step number 1, write the equation and check if the equation is balanced. So let's write number 1 now. Let's take step number 1. Step 1, and our step 1, I said we write the equation and check if it's balanced. So what are the equations? We are decomposing calcium trisulcarbonate 4, right, to give us 2 things. And since we are looking at the equilibrium constant, it's going to be on 2 forms, right? We are decomposing it to give us calcium oxide and what? And carbon 4 oxide. So let's check if this is balanced. Of course, you know this is an aqueous solution, right? And our calcium oxide is solid, and our carbon 4 oxide is a gas. Alright, so let's look at this now. In this form, let's check if the equation is balanced. We have 1 calcium here, we have 1 calcium here, right? We have 1 carbon here, we have 1 carbon here in the product sizes, and we have 3 oxygen here. We have 1 plus 2 oxygen, means the equation is balanced. And then step 2, we form our equilibrium constant formula. In the equilibrium constant formula, we said that Kp is the concentration of the product, right? Concentration of the product, the ratio of the concentration of the product to that of the what? Of the reactant. And in this case, this is our product. This part is our product. Our reactant, sorry. This part is our reactant, and this part is our product, right? So we take the concentration of the product to the concentration of the reaction. So if you watch in this part, we have two products, right? So it's going to be simply the first one there, CaO. We have no coefficient here, so we just put our CaO here, calcium oxide, times this one here, concentration of carbon 4 oxide. And these are the only product we have, because we're taking concentration of product to concentration of reaction. I look at the product we have here, CaO and CO2. To our reactant, we have the combined equation of calcium tricarbonate 4. So we'll take our concentration of CaCO3, and of course, you know, there are no what? There are no coefficients here, no coefficients. So we're not putting anything at the top. There are no raised to any power. Of course, and we're dealing with equilibrium constant. There are no units, no SI units, right? Because they are reversible reaction of the product and the what? And the reactant. And then we say there is no new substances formed with respect to time. So in looking at it, this is just a simple equation or the simple format on how to do questions as regard to equilibrium constant. In the next video, we'll do another question as regard to this and see how it works properly. I'll see you in the next video, guys. Alright guys, number 2 question says we should write the equilibrium constant for the reaction of nitrogen and hydrogen to form ammonia. I told you the 2 steps. Number 1, write the equation and be sure it's balanced. So let's get step number 1. Step number 1, let's check if it's balanced. Let's write the equation of our nitrogen. We have our N2, which appears as a gas, plus what? Hydrogen, which is what? H2, which also appears as a gas, to give us ammonia, which is NH3, which also appears as a gas. Ammonia is a gas. And since we have an equilibrium constant for that, since the equilibrium equation, it's both a forward and a backward reaction. We have both a forward and backward reaction. If we look at this, we discover it's not balanced, right? Still on step 1, it's not balanced because we have 2 nitrogen here, and then but we have 1 nitrogen here, and then we have 2 hydrogen here, but then we have 3 hydrogen here. How do we balance this? I have a full video on how to balance chemical equations, right? I'll leave that on the description box so you check them and see how to balance equation. So I said in that video that in balancing them, we just add our moles. Right, looking at this, we have 2 nitrogen. What I simply do here is to put 2. Okay, let's rewrite this to make it easier. N2 as a gas plus what? H2 as a gas as well, to give me forward backwards reaction of NH3 as a gas. What I need to do simply, since I have 2 nitrogen, I simply put 2 here, because 2 times N gives me 2N, right? So this is balanced. But then I have 2 times 3 giving me 6 hydrogen, but I have 2 here. I simply put 3 here. 3 times 2 giving me what? 6 hydrogen. How do I write my equilibrium constant? My Kp. Well, fully aware that my equilibrium constant is the concentration of product, right, to that of my what? Concentration of what? Of reactant. So what do? It's simply, what's my product here? My product is that of ammonia, NH3, but then I have more here, a coefficient of 2, so I put the 2 here, right? Over, let's check for our reactant. I have N2, right? N2, and if you check, there are no coefficients here. But also for my hydrogen, which is H2, my H2, you discover that we have a coefficient which is 3, so I simply put 3 here. That's just the balanced form of how to get the equilibrium constant of our reactions and products. I'll see you in the next video, guys. Thank you.